Now, here is a problem that involves DC parallel circuits. In this circuit, three resistors receive the same voltage, 24 volts, from a single source. Calculate the amount of current drawn by each resistor, as well as the amount of power dissipated by each resistor. We can analyze the problem through this diagram. Next, we determine the givens in the problem. First, we have the volts, which is equals to 24 volts. Resistant 1 or R sub 1 equals to 1 ohms, R sub 2 is equals to 2 ohms, and lastly, R sub 3 equals to 3 ohms. In the problem, we are required to identify the current and power of resistance 1, 2, and 3.
This problem requires us to find the current as well as the power in each resistor. So, in order for us to do that, these are the equations or the formulas that we are going to use. So first one is V is equals to I total times R total. Next is the total current is equals to the sum of I of R sub 1 plus I of R sub 2 plus I of R sub 3. The next one is the total power, which is equal to the sum of P of R sub 1 plus P of R sub 2 plus P of R sub 3. So the next one is for the total voltage. The total voltage in a DC parallel circuit is just equal to the value of the voltage in each resistors. So we can say that V is equals to V of R sub 1 and also equal to V of R sub 2 as well of the P of R sub 3. So to solve for the power, we have three different equations. The first is I squared times R, and the next is V squared over R and also I times V. This one is for the total resistance, which is equal to the sum of the negative reciprocal of R sub 1 raised to negative 1 plus R sub 2 raised to negative 1 plus R sub 3 raised to negative 1. So this is our solution. For solving the current in each resistors, we can use the fundamental formula or the Ohm's law, which is I is equal to V over R. So for the I of R sub 1, we have V over R sub 1, which has the values of 24 volts over 1 ohm, which will give us a total current of 24 amperes. Next is for the I of R sub 2, which is V over R sub 2. So 24 volts over 2 ohms is equals to 12 amperes. And next, for the value of the I of R sub 3, we have V over R sub 3, which has the values of 24 volts over 3 ohms, which will give us a total current of 8 amperes. Now, for solving for the power in each resistor, since in this problem we already have the values of the current in each resistor and the voltage of the circuit, we can use the simplest or the easiest formula, which is IV or current times the voltage. So for the P of R sub 1, we have I of R sub 1 times V, which is 24 volts times 24 amperes, which will give us a total power of 576 watts. So for the P of R sub 2, we have I of R sub 2 times V, which is 24 volts times 12 ampere, which will give us a total power of 288 watts. And lastly, for the P of R sub 3, we have I of R sub 3 times V, which has the values of 24 volts times 8 amperes. And multiplying this will give us a total power of 144.